All right, hello everyone. Welcome to the National Weather Association's webinar Wednesday for September, Aviation Weather, where DSS meets the airways. My name is Stephen Kearney. I'm chair of the NWA Aviation Committee, and I will be your host for today's webinar. And I'm also joined by Tim Bryce, who will be manning the controls back there. So Tim, thank you. As the title implies, we will be talking about DSS and aviation weather from several different perspectives. I'm pleased to introduce three of my committee members who will be speaking today. In addition to myself, we're joined by Paul Suffren of the National Transportation Safety Board, Eric Prosius of FedEx Weather, he's a senior aviation meteorologist there, and then Sean Campbell, also a meteorologist there at the National Weather Service Center Weather Service Unit in Leesburg, Virginia. I was going to handle a few logistics here before we get started. All attendees out there in YouTube land will be able to interact and ask questions of our speakers throughout the webinar, either via the chat feature on YouTube or on Twitter using the hashtag NWAWebWed. Again, that's hashtag NWAWebWed. We will then read the questions and comments at the end of the webinar. And you can follow the discussion on Twitter using that same hashtag, NWAWebWed, or follow the NWA account at NWAS. And then lastly, this webinar is being recorded for later viewing, so you'll be able to see us as many times as you want down the road. Quick rundown here. Each of us is going to give a presentation, and then we'll follow that up with a Q&A session afterwards as time allows. So without further ado, I'm going to go ahead and introduce Paul Suffren. He is a meteorologist with the National Transportation Safety Board. Paul, take it away.
All right. Thanks, Stephen. Thanks, everyone, for the opportunity to come speak today about what the NTSB does, and I'll go ahead and share my screen here and get started. Not too many people know that the NTSB has meteorologists. We investigate quite a bit of aviation accidents and incidents. And so I'll just step through kind of a little bit of what we do. So the NTSB has 3 meteorologists, and we're not part of the FAA. We're not part of the DOT or anything like that. We report directly to Congress. We have no regulatory authority or anything like that. And we're a completely independent agency, so we need to be completely independent so that we are not biased by any particular company or other government agency when we're doing our investigations. And we have 5 board members who rule on our accidents and come up with the probable cause. And then we have many specialists. Most people know the NTSB for cockpit voice recorder, flight data recorder, that type of stuff. And they do work for us, but we also have any number of pilots, air traffic controllers, aviation experts in all kinds of fields. And we also investigate large marine accidents, if any of you are familiar with the Alfaro investigation. We also did that, and we do certain highway and rail accidents as well. Those are a little bit less defined there. So as far as how we're organized, we have 4 regional offices around the country. We have Alaska, Western regions is based in Seattle, Denver for Central region, and Eastern regions kind of near Washington, D.C. And again, we investigate a host of transportation issues, accidents, and incidents, but mostly it's in aviation. We investigate every single aviation accident that occurs in the United States, and then if there's an American part, American person, or American plane, and anywhere in the world, we at least have one person kind of looking at that investigation and potentially helping out foreign countries that are the lead agency in those other investigations there. So we determine a probable cause and make recommendations to prevent similar accidents or incidents from happening again. In addition to the accident and incident work that we do, we also do special safety studies if we're seeing a lot of accidents or incidents in one particular region or one particular area or one particular feature from an airplane or other modes of transportation, then we'll look into those areas there as well. And again, we are charged with fulfilling the United States under Annex 13, which means that we help out with the other foreign agencies when there's an American part, person, or plane on board there as well. So we look into those. So digging a little bit into what the meteorologists do, the 3 of us that work for the NTSB, we have kind of 2 main themes. We review and determine exactly what the environment was. So was the plane flying in icing, flying near a thunderstorm, flying in clouds, all of those host of issues going on. And then on top of determining that, we evaluate the weather products and services. So was the pilot using a private company vendor weather information? We're using National Weather Service, FAA information. And if it's a larger carrier, did they have a dispatch? What were the pilots viewing there? And then we regularly collaborate with our air traffic controllers quite a bit and our operations folks who are former pilots. And human factors, there's always a human factors element to any of our investigations. Specifically, Get There IDIS is quite involved in a lot of our investigations and folks doing that. So we regularly collaborate within the NTSB to figure out the probable cause information there. So I thought I'd step through a few examples of why it's relevant, and one GA1, General Aviation one, and then one Part 121, which is a larger commercial carrier that more people are familiar with there. So here's an accident example of a VFR flight, or Visual Flight Rules flight, so flying outside of clouds. As a personal flight, it was a husband and wife team. They were flying back from Tennessee, Bristol, Tennessee area, going towards Detroit, Michigan region. They got a official weather briefing from flight service that day, and talked about potential weather activity in between their flight. Unfortunately, led to 2 fatalities. You can see the METAR there at the bottom of the screen shows 7 miles visibility, moderate rain and thunderstorm activity, and lightning distant all quads in the remarks section. So something definitely to look after there. For the surface chart that day, you can see from the flight plan that goes from northeastern Tennessee all the way up to Detroit. There was an outflow boundary located over central Ohio. This was the summertime. Summertime in Ohio, you don't need a whole lot of instability or moisture, and you have that surface front, or that trough there, so you're going to get rain, shower, and thunderstorm activity, which is what they got that particular day there. The Storm Prediction Center had a marginal risk out for severe weather, so not just general thunderstorms, which any airplane would want to avoid, but risk for thunderstorm wind damage and hail that particular day over Ohio there. And the pilots did receive a weather briefing at 6, and then around 6:15, and then one around 8 o'clock that day, and they discussed about a convective SIGMET, which is basically the severe thunderstorm warning for the aviation world. If there's a SIGMET out, planes are going to want to avoid those particular areas. And they discussed the SIGMET that was in between their departure there in Bristol, Tennessee, and the one that was, and then their destination there in Detroit. So they made a little bit of a correction or a change to their flight track, and went a little bit further west. And they said they would contact flight service while they were up in the air to get further updates on the SIGMET activity. So here's a picture of the airmets and SIGMETs valid at the time, and the SIGMETs are in the red shading there. You can see the very southwestern tip is in between their flight of Tennessee going all the way up to Detroit. The other little boxes on the screen, the purples, are airmets, which are kind of areas for pilots that want to avoid flying in clouds, whether it's near a mountain or clouds near the surface. They want to avoid those areas. And then there's other orange boxes up there, which are airmets for turbulence. For people that don't like bumpy flights, you want to avoid flying in those areas. And there's potential wind shear issues that could cause a particular issue, especially for general aviation flights. So if I step forward through time, you can see the SIGMET just goes further and further southwest through time and goes over the area that they're flying. And then here's a visible satellite loop around the accident time. You can see definitely cumulonimbus clouds firing along the surface trough right at the accident site at the accident time there. And they're flying to the north. And then I've loaded a weather radar loop of the WSR-88D data with the flight track there in purple. You can see it heads basically straight north, and when they get close to the convective activity, they start to do a couple of 360 loops. The black dots on the screen are the lightning activity, and as you can see, they head right into that moderate to extreme precipitation, or DBZ values greater than about 50 or so. Right at the accident time was what they were flying into. You'll notice before that there's kind of a little hole up to the north-northwest of their flight track, or about the 11 o'clock or so, 10 o'clock, 11 o'clock. And this is a hole that the air traffic controller, which they were discussing or talking to at the time, was trying to tell them about. So they requested assistance from air traffic control, and kind of air traffic control gave them two options. One would avoid their precipitation altogether and kind of go westward to west of Ohio and avoid that. Second option was to split the weather, and they chose the second option to try and split the weather. And they had two GA flights to move ahead of them, and didn't really have any problems as they're going through. But as you saw, that hole was quite large, and so those flights weren't in any cloud. But as is often the case in thunderstorm activity, those holes close quite quickly. And air traffic control did a really good job of issuing the intensity and distance of the precipitation. They were trying to give them some help, and then they were handed off to the next air traffic controller in the next sector, who didn't necessarily have the full context of what they were trying to look at. And air traffic control tried to suggest some changes of course and go to their 10 and 11 o'clock and kind of hit that or go through that hole there. And we're not sure necessarily of what they were, what the pilot was looking at in this particular case. So I have an image here of the location at 10:35, and you can kind of again see their location there. And to their 10 or 11 o'clock, there's that hole. And we don't know if the pilot, he wasn't flying in a big enough plane to have radar in the nose cone, but we don't know if they had a electronic flight bag or a tablet like an iPad, which can get some delayed weather in flight. And so we don't know if they were looking at that, and that's why they continued to go to the east there. But they wanted to avoid that. And as you can see, they do a couple of 360s trying to they get lower in altitude there at about 10:38, and then that's basically around 10:40 is when they fly straight into the thunderstorm activity. I have a kind of a 3D view of the imagery. We have the air traffic control flight track there in the blue dots, and then DBZ values of about 30 is there in the green, and then 50 is the bigger cells there, kind of the orange and yellow. And if you do kind of lower down view, you can kind of see they flew right into that thunderstorm activity there and had an in-flight breakup. And here's kind of an image of what the in-flight breakup and then their subsequent hit of the ground later on there in Ohio and the accident scene there. And here's another image a little bit closer in. So the NTSB determined the probable cause for this accident was the pilot's decision to fly into known thunderstorms because he was given that information via air traffic control, and it resulted, unfortunately, in the in-flight breakup there. So why is all this important? So the NTSB every year has about over 1,000 general aviation accidents that we deal with, and most of those are just something not necessarily a fatal one. Most of our accidents that are fatal is only in about the 250 to 350 range. But as you can see from the statistics there on the screen, that weather-related accidents are about a quarter to a third of all general aviation accidents that we see every year. And if it's a fatal one, usually weather is involved about 30 to a third of the time. So it's definitely plays a large role in a lot of general aviation accidents that we do see. And if we break it down by weather category, most of those accidents are wind related. So that's that's a small plane, a general aviation plane landing with a wind gust and landing, accidentally getting a crosswind, a tailwind, something like that, and they break the wheel, and that's enough to cause what we classify as an accident. And then from there, most of those are not fatal, and most of those are small-time pilots or things like that. And then, but where we do end up having a lot of issues are general aviation flying in clouds that they're not used to, precipitation, thunderstorm activity, and when it's a light condition they're not used to, so flying in the dark. So for example, maybe the pilot is used to flying between these two small airports for about 50 miles in the daytime, they have no issues, but all of a sudden now they're flying at night or right around sunrise or sunset, and you get that low fog or low clouds that form, and they're not used to that, and that results in an accident, or as we saw in the previous example, flying near thunderstorm activity or icing conditions aloft in the wintertime especially. So that's a lot of what we deal with. And then as far as why I wanted to share this today is I broke it down as far as the number of general aviation fatalities that we have all the way on the left side of the graph there. You see we have about 110 to 130 or 140 a year. And then I grabbed all the National Weather Service statistics from 2014 as far as the total number of fatalities for lightning and tornado and thunderstorm wind and cold and heat and flood and rip currents. If you add all those up, they don't even add up to the general aviation fatalities dealing with just weather that we see in a given year. And the flooding one does fluctuate quite a bit. So here's the same graph for 2015, and as you can see, we had some hurricane-related issues there in 2015, and so that's why the flooding one fatality number is so much higher. But you can see on the general aviation side, it's very pretty stable there, as between about 100 to 130 folks dealing with weather-related fatalities every year, flying small planes around. So it's definitely relevant and an issue that we're continuing to look at and trying to find ways to make folks safer when they're doing that. So, and quickly, I just want to touch on one more example here. This is more of a commercial flight, which most of us are more used to dealing with. This is the Delta flight that went through social media back in 2015 or so. They encountered hail as they were flying. The scheduled flight was to go from Boston to Salt Lake City, and they diverted to Denver after encountering hail there in southwestern Nebraska. And then here's a weather radar loop of the time with the actual air traffic control data, and then the dots of the location at the time there. You can kind of see they're flying. They're trying to split this hole here, and then the cell develops right there as they're trying to go through. So we got the actual air traffic control flight data that they were giving at the time of the accident there with the. So rather than having 256 colors like most of us meteorologists are used to, air traffic controllers just use 3 colors for moderate, heavy, and extreme precipitation there, with the extreme being that kind of radioactive green color. And you can see the incident aircraft there as the Delta kind of off to the right side of the screen. So 13 minutes before the incident, there's an American flight and a Southwest flight, both circled in yellow, that are heading eastbound. And they're talking about the weather that they're encountering. They fly basically right through an updraft, and they say, yeah, where our temperature sensors outside are showing a lot of warming on the temperature side. And the Delta flight is confused, and the pilots don't necessarily know that the American and Southwest flight are heading eastbound. The Delta flight thinks that they're heading westbound there. So there was some confusion between the pilots, and it wasn't necessarily given by the controller where everybody was. So there was a loss of situational awareness that we deal with there. And then about 3 minutes before the incident, you can see the Southwest flight and the American flight are well east of the thunderstorm activity, but the Delta flight is, at this point, they're picking up on their weather radar on the nose cone that they're going to an area that's definitely going to have some issues. And then about 45 seconds post-incident, you can see they're right in the middle of the thunderstorm activity. Not only we saw, in the WSR ADD data, but also, projected to the air traffic controller there as well. So that's more of what we deal with more on the commercial side. Fortunately, there hasn't been a weather-related commercial accident in quite some time, but there are a number of incidents every year, and we more significant ones that have issues. We look at those. So we do put out resources, not only recommendations, but NTSB puts out safety alerts, which I've highlighted here. This first one is talking about the NEXRAD age. A lot of pilots use their electronic flight bag or their tablet, and they have NEXRAD available on there, but they don't necessarily know that the timestamp on the bottom right of the screen is when WSI or ForeFlight or XM Weather are sending up that image. It's not when that data is actually current. And so people are trying to split the weather with using old imagery there. And we just finished a study on PIREPs and trying to get pilot weather information available for everyone, for meteorologists, for air traffic controller, and for all pilots, not just general aviation or commercial folks, and trying to make it relevant there. So it's a number of the issues that we deal with on a given basis there. And with that, I'd like to hand it back to Stephen.
All right, thanks, Paul. I do appreciate what you're doing there as well. And as you can tell, obviously several impacts there to aviation, and has unfortunately resulted in quite a few fatalities over the years. All right, so I'm going to go ahead and share my screen here, as I'll be presenting next. All right. There we go. All right, like I mentioned before, I'm the NWA Aviation Committee Chair. For the past 6.5 years, from about November 2011 to August 2018, I was a meteorologist with the National Weather Service Memphis Center Weather Service Unit. And less than a month ago, I actually made the move to San Angelo Forecast Office. So, but did quite a bit of work there with all kinds of things, aviation outreach, and of course, plenty of work there to protect aviation interests there in the Memphis area. So what I'm going to be talking about today is mainly kind of an overview of what we do at a CWSU, and then touch a little bit more on what we do there, what we have done there locally there at the Memphis Center Weather Service Unit. So I'm going to start off with a few statistics here. According to the Bureau of Transportation Statistics, about 1.8 million passengers each day board airplanes, and each day over 54 million pounds of freight are loaded onto cargo planes. And each day, weather is going to affect every single one of these aircraft routing decisions. Some days more than others. But you get the idea. There's going to be a lot of impacts there no matter what. So just a brief history here. Back in 1977, Southern Airways Flight 242 crashed in New Hope, Georgia. The NTSB confirmed that thunderstorms were the cause of the accident. As a result of this, NWS meteorologists were implemented in each one of the FAA air traffic control centers, about 21 of them around the country. And the idea behind this was to provide detailed weather information and decision support to aviation customers, both on-site and off-site. And this way they can work side by side in the same room to work together to help make a much safer airspace system. So there's a view here of all the 21 air traffic control centers here around the country, located in a lot of major cities. The one, of course, I was located there for the past 6 years was at Memphis, and we're kind of watched weather for air traffic there across the lower Mississippi Valley. So zooming in here a little bit, our operations, of course, is this region here with our neighbors surrounding us there. We're located there in Memphis, Tennessee. And just for comparison here, I'll overlay the forecast area, county warning areas. And as you can tell, we had a very large area to watch for in terms of weather. So there were a lot of challenges. Oftentimes there are two systems. This made for a very challenging day. So what do we do there? Well, I have an NWS forecaster is embedded within the FAA operations, and the whole idea is to be in-house with the customer. And I like to say this is similar in some ways to being an NWS incident meteorologist or an IMET. The main difference, though, is that we're trying to prevent an incident from happening in the first place. All right, so two of the biggest things to do is give 2 formal briefings per day, along with additional face-to-face briefings as needed. And then a directive came down last year, too, to also provide 3 recorded controller weather briefings there throughout the day. Now, the people we briefed, for the most part, were traffic management planners. They kind of looked at the larger picture there, about 4 to 6 hours. Individual controllers are just the ones who are actually talking to the airplanes, generally thinking about a 10-minute world out ahead of them. But they also need to have weather information provided to them as well, and provide tactical briefings to them as needed. Also have several event-driven products that were issued. The Center Weather Advisory is a 0 to 2 hour text product, which is broadcast by the traffic controller as an in-flight advisory. They read the statement as is. And this is kind of similar to a polygon warning or even like a nowcast. So in this example here, and Paul showed an image, of course, there about some air traffic there with weather overlaid. And this is what a controller's position is looking like as you're keeping your air traffic separated there en route. And it's their job to watch, of course, the weather that's affecting the air traffic, and this moves along. And they'll also get the messages like the Center Weather Advisory located at another screen. They can acknowledge that and read it out loud to everyone on frequency. So here's an example of a Center Weather Advisory that was issued by a Houston Center Weather Service unit. And as you can tell, similar to a polygon warning or a nowcast, just kind of showing areas of concern. And in this case, you have a point-to-point spots there. And then, of course, they're describing the hazard there: area scattered showers, moderate heavy precipitation. But the key thing here is that they show the movement as well as tops. And then tops are very critical here, much more critical than what you'd see in a forecast office environment. But they try to keep it brief, very simple, because they don't have a whole lot of time to make a lot of decisions. The second big thing that's also issued in terms of text product there is the meteorological impact statement. And that's a much longer term product, about 6 to 12 hours. This is usually meant to be an Outlook text product for the most part. At some Center Weather Service units, graphics are issued in lieu of a miss. At Memphis, we actually discontinued the use of the MIS a few years ago in favor of graphics. That seemed to go better with customers. Lots of coordination takes place. You have one person on duty at a time, so a lot of coordination there, both with your internal customers as well as other NWS customers out there. In this case, though, we did have to coordinate there with the Memphis Forecast Office on the TAF, also with neighboring CWSUs. We're trying to coordinate CWA, a Center Weather Advisory, and it's affecting hazard there that crosses the boundary between both center airspaces. Oftentimes you have to coordinate that to make sure you're not overlapping each other or delivering a different message. Also coordinated with the Aviation Weather Center. Paul there mentioned SIGMETs and AirMets, and so we coordinate with them as well. Same thing to get a consistent message across. We also coordinated on a product called the TCF, or Traffic Flow Management Convective Forecast. I'll talk about that more here in a minute. And then Memphis there, we were a little unique because FedEx also has their global super hub there in the area, and we did collaborate with them on quite a few overnight planning operations. Eric will cover that in a little more detail when he gives his talk next. So several services challenges there when you're working alongside the FAA. First off is that air traffic managers are not meteorologists. All right, this should go without saying, but it's easy to forget that sometimes. As a result, you want to focus on using non-technical wording, things like cold front and jet stream. They're familiar with that because they do have some basic weather training, but things like positive vorticity, cold air advection, that's just going to cause confusion there, so you don't want to be doing that. When you're working in a partner's environment like that, you should learn to speak their language. How will this weather affect air traffic? Things like what routes are going to be blocked by thunderstorms. We had questions like, is it a broken line? Is it a solid line? How tall do you expect it to be? Again, thunderstorm tops are much, much more important there than in a forecast office environment. Lastly, flight levels. Pressure levels mean nothing to them, so you have to talk in flight levels in tens of thousands of feet. So again, you have to talk in their world and figure out what impacts them the most. And then I like to say this, briefings, all right? Keep it short. They don't like a long-winded briefing for the most part. They like to say, what is it? How's this going to affect us? What's the biggest threat? And just keep it simple. And then lastly, of course, I mentioned this before, but you're it. You have one forecaster on duty at a time, and oftentimes you have to juggle multiple requests or just make a call with what experience you have. And there's a lot of learning that goes on in this case, but it's also a great way to develop relationships with the partners there in the room. So here's an example here of a DSS we provide during en route weather. In this case here is a line of thunderstorms from just north of Dallas-Fort Worth, northeastward up into the Ohio Valley. And of course, there's Dallas-Fort Worth, and there's Memphis there. In this case, commercial aircraft generally I fly at a cruising altitude of about 25,000 to 40,000 feet, depending on where they are and their capability. In this case, though, this section of thunderstorms had tops to about 30,000 to about 35,000 feet. And then this section here north of Dallas had had tops much higher, about 45,000 to about 50,000 feet. And notice there's nothing really impacting Dallas itself. They're actually still running pretty good. The impact then is going to come in en route impacts. So on a typical day, this is actually the predetermined route that a lot of aircraft like to fly here in order to get into Dallas-Fort Worth. Very busy airway through that area. Obviously, there's a problem with this. They can't take this way because this area is going to be blocked by large thunderstorms. So it's at this point then that we'd be asked, how long is this going to continue? Is this area going to continue pushing northeast? Are the tops going to remain high? Are there going to be any gaps? They like to look for gaps. Any way they can kind of feed a few airplanes through. And if we tell them no, it's still going to remain pretty solid, then they're going to talk with all they're going to talk with all of their surrounding facilities here and implement a coordinated reroute around the weather. So this is the safe option to do. However, this does lead to increased fuel cost and also can cause delays. So they don't like to do that unnecessarily, but safety is one of their biggest issues, and they want to make sure to ensure that. So ideally, they like to they like to know where the weather is going to be before they even implement the reroute. That way, they can implement the reroute ahead of time before the weather even starts developing. And one of the ways we do that here, I mentioned this earlier, the TCF, or Traffic Flow Management Convective Forecast. And this is a depiction here at about 2 hours apart of areas of higher echo tops there. Anything that's going to have a top higher than about flight level 290 is going to be depicted here, and also how much coverage. So in this case, this is pretty sparse coverage. I'll show another example here in the upper Midwest. A little harder to see, but it's actually medium coverage. To kind of pick out the areas there that are going to be much more impactful and cause much more blockages. As you can see, a lot higher tops here around the country as well. This product here is actually initially created by the Aviation Weather Center, and then it's spanned out to all the CWSU forecasters as well as airline forecasters. as well. And every 2 hours, they'd all jump into a chat room, and then they see the maps and they say, "What do you think? What changes would you like? What do you think would be better?" And we can draw our changes on there. We can discuss that based on what we think is the local impact or meteorological conditions out there. And this way, we can provide a unified message to the FAA, and each one of these air traffic control centers can coordinate based on a unified, collaborated weather message. So shifting gears here a little bit, another thing that was unique about us there at Memphis CWSU is that provided the support for the cargo operations. And of course, Eric probably covered this a little bit more in detail in his presentation. But just to kind of start off here, Memphis has the world's second busiest cargo airport by volume. And each night, about 150 cargo aircraft arrive between about 10 p.m. and 1 a.m. That's each weeknight. Now for the overnight impacts here, this is actually several different arrival gates here, 7 of them in total. They'd like to feed all of them in. That way they can bring them all in without in a very organized fashion. In this case, though, let's say we put a line of thunderstorms here over central Arkansas. Now, what does this do? Unfortunately, this causes a big problem. It effectively blocks these 3 arrival gates, and as a result, they'll have to actually move aircraft here over to different arrival gates there. Problem is, though, that does cause increased traffic. It does have the potential to cause delays, and delays mean lost money there for FedEx or any other aircraft that are coming into the area. So again, we try to help out as best we can by providing weather information to help plan that out, so we know where the weather is going to be, and they can plan that out several hours in advance. Here's an example of what we provided there for an overnight briefing to the TRACON as well as the air traffic management unit there in Memphis Center. The key things we're showing here are what impacts are going to be on the arrival gates, and green in this case shows pretty unlikely in terms of a chance of thunderstorms, so that looks good there. And then also provide the weather for each hour during the arrival between about 10 p.m. and about 1 a.m. and by about 3 a.m. ideally they'd like to be starting to push planes out for departures. In this case, looks like a pretty quiet night with pretty light winds, good ceiling conditions. We also provided the winds at 1,000 to 2,000 feet there as well. So this looks actually like a pretty good night out there for them. Another case, though, if we were expecting something like a squall line to be passing across the TRACON area, it would look something like this, okay? And what they really like is to have the red, yellow, and green traffic light signal out there so they can pick out quickly, okay, is this going to be a usable gate or not? In this case, we tried to show the progression of a squall line there across each one of the gates. And this way they can show what the gates are going to be available at what times. And that way they can kind of stagger the arrivals if they need to, and just try to avoid delays as much as possible and avoid holding as much as possible as well. In this case, there are pretty strong southerly winds expected for that night. And we also showed the best time of arrival there for thunderstorms. In this case, would be about midnight. So again, they like us to know when stuff's going to be available and the start and stop time there for these hazards. So I'll wrap it up here with my last slide before I hand it off to Eric. The mission of the CWSUs has fit the National Weather Service Weather Ready Nation roadmap very well here. And one quote from that roadmap says, IDSS meteorologists will be embedded in core partners' operations. Well, guess what? CWSU meteorologists have been doing this for almost 40 years. The impacts to safety, society, and the economy. Aviation weather truly is at the heart of decision support. So I'll wrap that up then here for my portion of the presentation. I'll go ahead and hand that off to Eric there. Pretty good segue there as he'll talk about FedEx operations.
All right, thanks a lot, Stephen. And that, yes, definitely is going to be a good segue into what we're going to discuss here, which is talking a little bit about the FedEx operations and aviation meteorology here at FedEx. I am a senior meteorologist for FedEx. I've been with the company for about 14 years. And one of the first questions I almost always get when I say I work at FedEx as a meteorologist, the question is, oh, I didn't know they had meteorologists at FedEx. And then their second response is, but that makes sense. And that's usually once they find out kind of what we do, it does make sense because when you've got a large cargo airline flying all around the world with weather being one of the primary factors in how that operation works, it definitely benefits to have meteorologists on staff to handle that. So just to give you a little bit of a background of some of the fast facts here about the airline itself, FedEx Express has now 6 domestic hubs, Memphis, Tennessee being our super hub, which handles most aircraft, and basically we can fly pretty much around the world from here in Memphis and get a package from any point in the world to any other point in the world connecting through Memphis. Also have a second pretty large hub up in the Midwest, Indianapolis International up there, serving the East Coast, Newark, outside of New York City and New Jersey is our East Coast hub. Another Eastern U.S. hub in the Mid-Atlantic that we actually just turned on a week ago, Greensboro, North Carolina, is handling a lot of the Mid-Atlantic traffic now. Out on the West Coast, Oakland for the in the Bay Area, and then down in the Southern Plains, Alliance Fort Worth, which is a one of the larger airports there in the Dallas area, handles the Southern Plains. Internationally, some pretty large hubs as well. Our main European hub is in Paris at Charles de Gaulle Airport. We also have a secondary hub at Cologne, which is in Germany. Liège is in Belgium, so those all handle a lot of the European traffic. And then in Asia, our main hub there is at an airport called Canton, which is in Guangzhou, southeastern China, just about right on the coast, very near Hong Kong. And then finally, Anchorage is kind of a transit point for us as well for some of our trans-Pacific traffic to drop in and fuel up if they need to, and a little bit of sorting that goes on there, but mostly is just a stop-off point. The airline employs over 4,500 pilots. There are over 200 aircraft dispatchers that are responsible for filing all the flight plans with the FAA for all of those flights. And before a couple of the larger airline mergers, commercial airline mergers in recent years, we were actually one of the largest aircraft fleets operated by a single company in the world. We currently have 656 at last count aircraft. 388 of those are mainline jets, mostly wide-body airplanes. And then there's also a network of 286 feeder aircraft that operate into from some of the larger cities out into the smaller cities that those feed out to. So a little over 650 aircraft, and that continues to grow. We have a fleet of narrow-body aircraft, 757s, almost 120 of those now, and we are ramping up our Boeing fleets, 67 67s, 35 777s, which fly long-haul flights, transatlantic, trans-Pacific primarily. A lot more of those on order. And then some of the older aircraft that are still flying, MD-11s, MD-10s, which for those of you who are familiar with the DC-10, that's basically a converted DC-10 from a 3-person to a 2-person cockpit, all glass, and then a fleet of Airbuses as well. So we have a wide variety of aircraft types, and that helps to so that we can, if there's a particular problem with an aircraft manufacturer or a certain type of airplane, we've got a lot of diversity there in the aircraft types. As far as the department is concerned, our FedEx Meteorology Department started in 1986, which was about a dozen years after the company was founded. After that time, the airline was quickly growing and realized that having an in-house meteorology department was going to be a very wise use of funds to be able to get the latest information pertinent directly to the operation. We are a 24/7 operation, 365 days a year. There's always a meteorologist on staff here in the Global Operations Control Center, which is basically our airline dispatch center. They're one of our primary customers, so we work very, very closely with the dispatchers. They're the ones that are planning all the flights, the amount of fuel that's going on those planes, the cargo and everything, and weather is one of the primary drivers. They're also basically the direct liaison to the air crews that are in the cockpits. The way that we operate, basically the pilot and the dispatcher are in joint control of each aircraft that flies. So they make decisions together, and so they are also exchanging the information, weather information and other information directly between each other. Our department is an EWIN certified department. It's an Enhanced Weather Information Services, or EWIN certification, which is an FAA certification that basically allows us to be the primary source of forecasts for basically all of our trunk flights worldwide. There's a couple of minor exceptions there. But one of the chief duties that we have for the airline is to write TAFs, or Terminal Aerodrome Forecasts. Those are basically point forecasts for the airports that we fly into. They extend out generally about 24 hours and cover things like cloud decks, precipitation, wind, and those sorts of things. So we do write those TAFs for many of the places we fly to. We currently write a little over 40 TAFs twice a day. Another subset of those on a third time during the day as well. The staff that we use to do that and all the other work that we do is 15 meteorologists, comprised of 1 manager, 11 operational forecasters that are doing the shift work, 24/7 coverage, and then also 3 support meteorologists, of which I am one, that serve in kind of an administrative capacity. We do a lot of the training for the department, introduction of new technology, and also some of the forecasting that happens during the daytimes, weekday operations for that. So it's a pretty big staff, but to be able to have 24/7 coverage, we have to have a staff that large. As far as the one of our biggest most time-sensitive operations. A lot of folks that are familiar with the FedEx operation know that we are an overnight carrier, or think of us as an overnight carrier, and that is true in some respect. The operation that goes on here in Memphis during the evening is one of the most critical for the kind of the global success of the network, because basically we have all of the aircraft that come in and go out are touching many points around the world. And so if things don't go well here in Memphis during the overnight hours, that ripples down very quickly down to the other markets. As Stephen mentioned earlier, we do have over 150 aircraft that arrive between 10 p.m. and 1 a.m. here in Memphis on weeknights. During that midnight hour, if you look at that Universal Time Coordinated, or Z time, we are the busiest airport in the world at that time of day. So we have those 150 planes that come in roughly 2.5 to 3 hours. Also during the dayside operation, we actually also have a pretty good amount of operations here in Memphis on the dayside. About 100 arrivals. They're spread out a little bit farther, so it's not quite as compressed of a time schedule, but that operates 6 days a week as well. And then we also have weekend night operations, and that primarily is for international operations. So that kind of covers how Memphis operates. Now, the other hubs are slightly smaller in scale. Indianapolis is still pretty large. They have about 80 aircraft on weeknights. And then the other operations are significantly smaller than that, but serve their primary regions that they operate in and out of. Obviously, besides all of the other things that can that can come up when you're dealing with a large airline, weather plays a major role in how we operate, particularly here in Memphis. And so we have a pretty good focus on the Memphis operation, because again, as Memphis goes, the rest of the system goes. And so when we have a nice VFR night where the clouds are high and dry conditions, not much wind to play with, we can land here in Memphis on 3 runways, typically about 90 aircraft an hour, which is sufficient to be able to bring in all of the planes that we have scheduled. The problem is when the wind or when the weather drops. So if we have a low cloud ceiling, maybe the wind is fine and we don't have any precipitation, but we have a cloud deck at 800 to 1,000 feet. That arrival rate drops significantly. And usually what that does is eliminates one of the runways that we can operate on. And so in IFR conditions, we may be down to about 60 to 62 aircraft an hour, or perhaps even fewer than that. When that happens, now we can't by schedule get all 150 of our airplanes in the time that they're allotted to. And so now we're, just by having a cloud ceiling that maybe is at 1,000 feet, we have decreased the capacity of the airport to handle what we're going to be pushing in. Other things that can control that also, things like strong surface wind or low-level wind, certainly thunderstorms and other things all play into that as well. So weather certainly is one of the key drivers for how things go here in Memphis. So one of the products specifically that we produce that is somewhat similar to what Stephen mentioned that they do at the CWSU is a specific forecast for our Memphis inbound during those weeknight operations. We actually push this product out in the early afternoon. So by that time, we're already starting to look ahead to the evening, planning how we're going to be able to operate. Are we going to have certain weather conditions that will be factors in how the operation works, and are we going to have a reduced capacity and have to adjust the demand based on that? So this is an example of what we call our ATC outlook, and it has a hour-by-hour interpretation of the weather conditions, surface winds aloft up to 3,000 feet, ceiling and visibility, weather conditions, and then a little discussion that goes along with that that kind of describes the weather overall across the United States, because certainly weather en route, as Stephen mentioned, is also going to play into how smoothly things operate for us during the overnight hours. So you see also there on the right kind of the way that that the Memphis airport is lined up. On the very north side of that, or the top of the picture, is where the FedEx ramp is located. So that's where we park our 150 airplanes during those overnight hours. And so the optimal configuration is for us to land from the south to the north, which means all the planes are landing towards the hub, and so there's a much shorter taxi time when they once they get on the ground. Airplanes are designed to fly, and so they are much more efficient when they're in the air than when they're on the ground. And so we want to reduce that amount of taxi time as much as we can. So a north operation is preferred, landing towards the hub. And then when we depart out of the hub, we want to depart off to the south because, again, it reduces the taxi time, the amount of time they're on the ground. We can get those planes off the ground even quicker. So wind direction plays a key role, and when you have a wind direction that doesn't allow you to use that the highest capacity of the airport or land as quickly as you would under normal conditions, you're increasing the taxi time, and it's taking longer to get the planes into the hub, and so that kind of ripples through the entire operation and slows things down as well. So that's one of the products that we look at. It's provided specifically to our ATC coordinators that are here within FedEx that coordinate with the FAA on how we're going to operate that particular evening. It also does happen to go out to some of the local FAA personnel, so they get an early look at what we're thinking for that night as well. So some of the coordination that Stephen was talking about takes place from our side as well. Some of the other, a couple of the other key products that we produce, especially in the winter time, we have what are called snowcons, which are winter weather forecasts. These would be similar to like a winter weather advisory or winter storm warning that the Weather Service would issue to the general public. We issue these primarily for our 3 eastern U.S. hubs, for Memphis, for Indianapolis, and for Newark, the places that get the most winter weather, or it causes the most problems when it does occur. We don't get a lot of it here in Memphis, but because we're in the South, we don't deal with it well, as you might expect. And so as much heads up as we can provide is beneficial. We basically use kind of a DEFCON type index from 5 down to 1, which just describes how far out we are from the precipitation occurring. And that forecast will also include things like what kind of precipitation is expected, when is it going to occur, how long will it last, and describe a little bit of the significance to the operation. Each one of those levels then triggers certain actions within the company to be able to handle that event, starting from 48 hours out down to the SNOCON 1 condition, which triggers things like extra fuel and so forth, to make sure that we're able to handle the operation as best that we can. One of the other kind of unique products that we do deals specifically with the international realm, and that is a mountain wave turbulence forecast that we do for the areas near the Himalayan mountains in China. And on the left side of your screen there, you can see kind of geographically the area that we're concentrated on for that. But we have some key routes that go from the southeast side of China down here where Guangzhou and Hong Kong are, near Taiwan. So that's our Asian hub. But our flights that transit from there to Europe cross through this area in the red box as they go over towards Europe or come in from Europe. And one of the things that we deal with there, as you can see on the right in the topographical map, is the Himalayan mountain chain. And so with mountains, you're going to encounter mountain wave turbulence on a semi-regular basis as well. So this forecast is kind of a text forecast. There's an example of one down here at the bottom. And basically what this describes is for each one of those routes that are in purple on the right-hand side, where is the potential for turbulence during what times and at what points along this route. So if you think of those kind of like interstate routes, the L888 route, the Y1 route, those would be like interstates, and each one of the little white points on there, they're called waypoints, but kind of think of them as little towns as you're going along the interstate, crossing through Kansas or Nebraska. And so we're describing where along that route to expect the turbulence, how strong it's going to be, and at what flight levels. The reason for this product is because we need to give them, those flights that are transiting that route, plenty of advance notice about the type of turbulence that they might encounter, because there's very large restrictions on how we can operate within Chinese airspace. And so basically, they need to know, because they can't fly into severe turbulence, what is our alternate route going to be well in advance before they actually get in the air and then try to have to take that alternate route. They actually plan that before they get off the ground. If they are going to potentially encounter turbulence, they might take the longer route, which is the black route that goes along the outside. It's farther from the mountains. Obviously, that's going to require extra fuel, extra time, significant delays. So it's not the preferable route, but it is one that would be taken if necessary based on the forecast for turbulence. So speaking maybe to some of the bigger challenges from an international carrier with this many aircraft transiting the world, what are some of the big things that we are dealing with? And I've kind of broken these down into three groups. The first one is kind of the large scale systems that are affecting multiple airports. So in this case, we'd be talking about things like winter storms, where it's a fairly predictable type of event, but it's going to cover a large area and it's going to last for some period of time. It's not going to be, like a thunderstorm that moves through in 30 minutes. Precip type changes and significant accumulations are significant factors to us, and so it's always a forecast challenge to handle winter weather, but it is one of those things that can affect several airports over a long period of time. Others, like landfalling tropical systems, are certainly right up there as well, and so we're here recording this in the middle of September when hurricane season has flourished. So we've had tropical systems in the Western Pacific. Last week we were dealing with a typhoon that went through Osaka, Japan, that produced significant damage. This week, multiple systems, including things like Hurricane Florence, affecting the East Coast. There's 4 or 5 that we're actually dealing with right now. So those are large scale systems that also are problems. Large convective systems, MCSs and so forth, these large mesoscale convective systems that can move through multiple airports. That's kind of one category. And those, again, are somewhat more predictable, but are going to still have significant impact. The second category is a little bit more transient type of weather, and it's also a little more unpredictable. So things are like air mass thunderstorms in the summertime, where you can shut down an airport for a period of time, but it isn't as long lasting. It's more easily recoverable. We don't necessarily adjust operations quite as much for those as we do for the large scale systems. But again, it's more unpredictable. Knowing whether an air mass thunderstorm is going to pop up over Atlanta at a certain hour of the day is not easy to forecast, but it is also a little bit more recoverable from. And then finally, some other more predictable things that might happen, but typically wouldn't cause problems for most people that are just transiting on the ground. But at high demand airports, things like compression winds, low level jets, strong winds that are going to affect the landing configuration and the ability to get into those airports. Dense fog, low ceilings and visibility are a pretty semi-predictable event, but when you get those over the wrong airports, they can cause significant issues as well. So those are some of the things that we deal with, and it's part of why we have a meteorologist on staff 24/7 here, is because these things can pop up, and we need to be able to provide the best forecast possible. As far as how we operate in severe weather, winter storms, tropical weather, and so forth, we only have 15 meteorologists, and their breaks are, you have to have your breaks between shifts and so forth as well. So we're somewhat limited on how we can handle staffing changes. We do obviously have additional staff that are around, especially on the weekdays, that we can assist with some of the duties as necessary. We handle a lot of the conference calls that will come up, and typically those end up being more on the weekdays, some on the weekends. But when we're in the planning stages, they like to get those in on the weekdays when we have better staffing. We can extend hours as needed. We try not to call in extra meteorologists on their off time, but if necessary, we can do that as well. We also will provide additional forecasting capabilities. We have new forecasts that we call rampcasts, which actually provide hour-by-hour detail for specific weather events. We do these now for tropical events that are going to affect major airports that we fly into, where we'll provide hourly wind direction, speed, and gusts for those airports, so we can the decision makers can decide what hours that airport is going to be affected, when can we get in, when can we get out, and kind of work around the weather. A lot of telecons take place, one-on-one briefings with whether it's management or whether it's dispatchers. We speak to pilots on a regular basis as well. So we're constantly doing briefings. And basically one of the main jobs of the meteorologist here is to provide an expert opinion on making these big cost-benefit decisions. We are not a federal government agency. We're a private company, so we have shareholders, and so the cost-benefit decisions do come down to a bottom line a lot of times. Safety is always first, but efficiency and making sure that we're trying to meet the needs of our customers is right up there as well. So decisions that have to do with things like moving aircraft proactively out of a danger zone, canceling or moving sort operations around. That's kind of tricky to do, especially at the larger sorts. But some of the smaller sort operations, we can move things around and flex that a little bit. Fueling, amount of aircraft fuel, that's obviously a cost decision as well, but you have safety ramifications to that. Duty time decisions for the crews, how long have they been operating? We don't want to get them into a place where then they're not going to have duty time to get out before a weather event hits. And one of the other big things that we like to pride ourselves on is a lot of the charitable efforts that we do as well as a corporation. And so one of our kind of mentalities is try to be the last out of an airport that may not be able to be operable for a certain period of time and the first airplane back in. And a lot of times when we are attempting to make that first flight back into one of these airports that's just opened after a major weather event, it is not because we're bringing packages into that airport and trying to start service back up. Typically, that first flight is going to have charitable relief on it. It's going to be a flight for the American Red Cross, Heart to Heart International, bringing in those relief supplies that are needed in that community to be able to kind of get that community back on its feet so that we can then start operations, delivering packages and so forth. So we like to pride ourselves on a lot of that charitable relief as well. Final comment I'll make with regard to our department is that we've talked a lot about the air side, but we are the corporate meteorology department. So anything that comes up from the entire corporation, we have extensive ground operations. We have very high level, high dollar shipments that might need special attention. We field all kinds of things. And so we basically can just provide the scientific expertise that the company is looking for whatever decision needs to be made. So that's kind of an overview of how we handle things here at FedEx.
All right, thank you so much, Eric. And I can speak on behalf of the CWSU there in Memphis. We are really fortunate to have a great relationship with you guys there at FedEx there right across the airfield. And I know a lot of the weather challenges we face there, at least in forecasting for the Memphis area, certainly were shared challenges. And I think we had victories together. We also had defeats together. And I think that's what helped to kind of develop a great relationship. So it was always a pleasure working with you there, and glad to be working with you on the committee now as well. All right, so we're going to pass it on here to Sean Campbell, who's the meteorologist there at the Center Weather Service Unit in Leesburg, Virginia. And I'll be sharing his presentation, so give me one moment. I'll get this rolling here. Let's see here. And does that look okay to you guys? Is that the right mode?
Yep. You're good.
All right, Sean, go ahead and take it away.
Okay, hi, I am Sean Campbell. I work at the ZDC Center Weather Service Unit. I'm going to be talking today about a 13 August 2018 thunderstorm event where the FAA actually enacted some severe weather avoidance plans, which are called SWAP for the Washington Air Route Traffic Control Center airspace, which is affectionately known as ZDC. Next slide, please. So I guess the first thing I probably should talk about is, much like Eric mentioned, we do have designated air routes across, particularly at least the continental United States, that are controlled by air traffic controllers and traffic management units. As Stephen mentioned, sometimes thunderstorms cause the FAA to take actions to avoid thunderstorms associated, or to avoid the hazards associated with these thunderstorms. So some examples would be rerouting aircraft, would be shutting down one or more air routes, and in the case of an airport, perhaps putting a ground stop into effect, which basically means that planes are not allowed to fly into or out of that airport during the time that that ground stop is in effect. Now, the slide that I have up here kind of shows ZDC's major traffic flows. It's very complex, as you can well imagine. Just the ZDC North overflights, which you can see in the key lifted on the bottom right there. We have flights to EWR, so Newark, LaGuardia, JFK, Philadelphia, and Boston. So those are flying over a lot of some of this traffic, and then that's flying below it. At the same time, we have flights that are going basically, again, to Philadelphia, to DC from the north or from the south. We have international flights that are flying through New York's airspace, through Boston's airspace. We have flights that are going to Richmond and Norfolk, both north and south. To the northwest, we have flights that are going off to the Chicago area, to the Detroit area, to the Cleveland area. To the southwest, we have flights that are going to Atlanta, to Charlotte, to Raleigh, Durham. And then we have what are called the Atlantic routes to the south. So you're flying down to the Florida folk, or to some of the Florida airports like Orlando, Fort Lauderdale, and Miami. And also some of them go towards the Caribbean and the Bermuda, the Bahamas, So we have all this to kind of take a look at and consider when we're trying to put a forecast together in terms of thunderstorms and how it's going to impact the air routes across ZDC. Next slide, please. So some pre-event highlights. We would arrive at about 5:15, assess the thunderstorm potential, look at models, look at the current situation, try to figure out what we think is going to happen over the next couple hours, next 4 hours, next 6 hours, next 8 hours. Then every 2 hours, as Stephen mentioned, we collaborate on that 4 to 8 hour traffic flow management convective forecast, the TCF for the National Airspace System, with the Aviation Weather Center, with other commercial airline meteorologists like Eric. And then we're also talking with the folks at the command center, the Air Traffic Control Center, a command center out there in Warrenton, Virginia. So there are some meteorologists there that we kind of collaborate with. No later than 6 in the morning, we're putting together our pre-duty weather briefing with some thunderstorm slides that those are for the air traffic controllers to give them some situational awareness. As Stephen mentioned in his briefing, we do this 3 times a day. So 6 a.m. is about the first time we do it, although I think we're probably going to head a little bit more earlier than that. It looks like in the future potentially. By 7 a.m., we are already briefing the thunderstorm potential to ZDC operations leaders at the stand-up briefing, which we give 2 at about that time. And then no later than 8:30, we're coordinating the international arrival and departure gate thunderstorm forecast with the Boston Air Traffic Control Center Weather Service Unit. And then no later than 10:30 a.m., we send what's called a swap statement to the ZDC Traffic Management Unit and the Supervisory Traffic Management Coordinator. Now, keep in mind, all this time, there may be thunderstorms ongoing, so we could actually be in the process of briefing folks like the Traffic Management Unit. It could be briefing folks like the TRACONs, which are the Terminal Radar Approach Control folks. We could be talking with the Traffic Management Officer for Washington Center. So, you know, we could be busy. We also could be issuing center weather advisories. We could be issuing the MIS, as Stephen mentioned. So it gets a little busy in the morning right before thunderstorms start to hit, if it's a really big event. Next slide, please. So here's an example of the swap statement. And the swap statement is kind of an interesting thing in that the swap statement is issued by at least ZDC, CWSU forecasters and other CWSU forecasters. And we're actually kind of forecasting the potential that the FAA is going to enact severe weather avoidance plans based on thunderstorm potential. So it's a thunderstorm forecast, but we're trying to kind of keep in mind how much volume the National Airspace System may have, what else is going on. Maybe there are military operations, and there are quite a few military operations in Washington Center's airspace. Presidential support. Washington Center has some places just off the coast that the military operates in, and if they actually shut those down, that kind of curtails the amount of space that we can use to, or that the FAA can use to route planes through. So in this particular case, we're looking at the swap statement. There are 4 swap forecast categories. One is swap expected, another is swap probable, another is swap possible, and another is swap not expected. So in this particular case, we had swap plans were expected for the DDC airspace. So we're looking at, again, in this particular case, the type of thunderstorm activity, so scattered thunderstorms, what time we're looking at them to develop. We'll continue to develop across Northeast ZDC and move north-northwest through the evening. Some type of organization, and it's kind of helpful to know if they're going to be clusters, because they might be able to route, they being the FAA might be able to route aircraft around some of these thunderstorm clusters. If it's a line or a line segment, they kind of want to know that. What the thunderstorm movement is going to be, how high the tops are going to be. And in some cases, we like to try to kind of pinpoint which jet routes are going to be impacted. So in this particular statement, you can see we just wrote impacts to all major jet routes are expected across the northern portion of ZDC. And then obviously, if you have impacts to the DC metros, that being Dulles International, Washington National, and BWI, that's going to cause some major impacts as well. So we try to highlight those as well. Next slide, please. So Stephen mentioned, we do coordinate what's called the TCF. This is a TCF graphic example from 13 Zulu on 13 August 2018. And again, it basically just highlights areas where we're expecting the best potential for either sparse coverage, that being 25 to 39%, or medium coverage, 40 to 74%, or even a line, which would be greater than 74%. And in terms of tops, what we're looking at in terms of maybe we could have 34,000 foot tops. And this is not necessarily going to be the highest cloud top, but it's basically going to be an average of the cloud tops within those areas. Next slide, please. So kind of zooming in on the 13th of August to the 6-hour forecast at 19Z across northern portions of ZDC, we see we had a sparse area. Again, that's 25 to 39% coverage where we were expecting tops at least 39,000 feet. Next slide, please. So in this particular example, this was the 19Z thunderstorm shot, essentially. So this is what was actually going on at 19Z. So you can see that area actually verified quite well with several thunderstorms, just kind of pockets of thunderstorms there. But that's across ZDC, that's enough to cause a lot of impacts, which we'll see on the next slide, please. So on the right, I've kind of highlighted some of the major air routes across the northwestern portion of ZDC. We've got what's called J75, which kind of runs northeast to southwest, kind of basically right over Washington, D.C. And then we've got J48, which is just to the west of that, again, also running northeast to southwest. We've got J6 just to the northwest of that. And we've got J518, which basically runs from BWI northwestward towards the Pittsburgh area and eventually out towards Chicago. And then we've got J220, which basically runs from Dulles International Airport on northward. So in this particular case, as a result of those thunderstorms, and this is just part of a swap day that happened, or a swap event that happened, there were much more impacts than this, but I just wanted to kind of focus on a couple hours worth of a swap event here. You can see at 1702 Zulu Z and Y, that being New York's airspace, or the New York FAA folks, stopped J220 until 000Z. So you can see we've got like 5 hours worth of one major jet route that's closed there. And then at 1725, and then times after that, we had several more jet routes that began being impacted. And essentially that just means they were shut down. So no air traffic can flow on those routes. So the FAA had to come up with a plan to route planes around some of these thunderstorms because those jet routes were being impacted. And then by 1930s, the ground stops for the DC metros, again, that being Dulles, DCA, and BWI, were also put in place. So again, this is just one kind of short little snippet of a swap day or a swap event for us. Next slide, please. So that's pretty much all I have. I just wanted to highlight what we did here today. So in this briefing, just kind of talked about a little bit about swap actions that the FAA may take based in part on several meteorological products, and kind of show part of an example of a swap event that occurred on August 13th, 2018 across the ZDC. That's all I've got. Thanks.
All right. Thank you so much, Sean. I'll round out our presentation part of the program today. If time, we're going to go ahead and take any questions we've had. Any questions that showed up in the chat feature there. Let's see here. I see one here that just came across. What is the process for getting hired as a meteorologist for a company like FedEx? Is there a call for hiring on, say, the FedEx website? And it looks like, Eric, that'll probably be a question for you.
Yes. So we do hire. Obviously, we have some turnover occasionally, and the postings for those are always on our FedEx careers website. I believe it's careers.fedex.com, and we are typically hiring folks with a little bit of experience, not those that are straight out of college. basically, we're looking for folks who have forecasting experience already, and then they can come in, learn our systems, learn how to apply it to what we do here at FedEx, and be able to hit the ground running pretty quickly. The training process is usually no more than a couple of months long, and so because there are times when there's only one person on a shift, say on a weekend, we try to bring you up to speed fairly quickly with the background knowledge of meteorology and aviation already in place when you come in, so that you can kind of learn how we do things here, and then before very long, you'll be possibly on the floor by yourself, be having to answer the different questions that come up. But yes, we do have positions available at times, and would encourage you to follow careers.fedex.com, or you can reach out to us here at FedEx as well.
All right, thank you, Eric. Another question here is it's probably going to be geared for Paul, but certainly any of us probably can answer this. Since the turn of the century, airline accident rates have decreased substantially. However, the general aviation accident rate is still high, and Paul, you kind of reflected that in a couple of graphics that you showed there. Why is this, and what can be done to improve this accident rate?
Well, that's yeah, like the commercial rate as far as Part 121 or commercial carriers, the larger airlines, has definitely decreased substantially. A lot of safety features and interactions, not only with the NTSB, with the FAA, commercial airlines have gone a long way there. On the general aviation side, yeah, we're still seeing quite a high rate of general aviation accidents every year, and it's a host of issues. The NTSB issues a top 10 or most wanted list, and a lot of the accidents that we're seeing not only are weather related, but also are loss of control type of issues that planes are seeing. So that's one of the ones we wanted to highlight this year. And so we work with the FAA and large general aviation agencies like AOPA or something like that, Airlines and Pilots Association. So we work with them to try and get the word out of things that are involved with accidents. So a lot of it is getting the word out, getting education to where pilots are, like if they're going to Embry-Riddle or North Dakota or something like that, talking to them at that point, and then they can make safer decisions down the line, and we can decrease that accident rate. But unfortunately, there's not just a magic bullet to cure all of them, but we'll continue to work with everyone to try and decrease it as quickly as we can too.
All right, thanks there, Paul. Any other input there from anyone else, Sean or Eric? Oh, okay, all right, that's fine. I can definitely add something else there as well. When I was at the CWSU, we did a lot of outreach efforts, things like pilot seminars, working with our local FSDO or Flight Safety District Office. That's actually the safety portion of the FAA. They try to do a lot of outreach there. And so I kind of say they're similar to a lot of public outreach events where we talk about tornadoes and severe thunderstorms and everything like this. This one was a lot more pilot focused, and so we tried to do that and tell them more about what we do and how to access our products and what these hazards are. And it was incredible to see too. Some were just kind of like, wow, this can happen. And we also did a major event last year, which was actually in coordination with FedEx. Did a huge event there called the Mid-South Wings and Weather Conference, and we actually held it at FedEx in their facility. And I brought a lot of GA pilots, brought a lot of meteorologists into the room, and we definitely was appreciated by all. Of course, Paul, you were a keynote speaker for that event as well. And I think overall it was a very good event because we had the meteorologists and pilots and air traffic controllers all in the same room, and we had pilots walking away from that event going, "Wow, I'd never spoken to an actual meteorologist before," and to hear their input and to see what they could do and to talk to them personally was like a brand new experience to them. And same thing with the meteorologists. That a lot of them, I guess, they may not have as much interaction with pilots these days, especially since we don't provide pilot weather briefings anymore, at least not official ones. And so as a result, I think some of that interaction may not be there as much as they can do. So I know we provide in Memphis, we've provided a lot of pilot seminars. I know a lot of forecast offices are doing little local events as well. So this is an area here that unfortunately is still seeing a very high fatality rate. And because of the unique impacts, a lot of meteorologists may not have as much training to be able to forecast those kind of unique impacts. But that's where we need to take time to learn from those customers and try to provide outreach to a lot of these this is a unique partner, because unfortunately that fatality rate is still far too high. I'll just put that out there. All right, so I'm going to move on to another question we got here. In recent years, new technologies such as GOES 16 and dual pole radar have been introduced. That's probably since the turn of the century. How do you foresee new weather products? Let me rephrase that. I'm sorry. How will the new weather products be useful for better DSS and improving aviation safety? I'm going to throw that to the entire group here.
I could comment on that first. I think first of all, having these new products, the things that are providing us more rapid updates, are certainly going to, first of all, improve the products that we're providing to the flying community. So the TAFs, the you know, the AirMets and SIGMETs and so forth. All of that can only be bettered by having more information that is more accurate, higher resolution. Certainly with the GOES 16 and GOES 17 satellite that's coming, you're going to get a whole lot more information out of that that can help improve those products. And I think a lot of the other things that that are coming along that we're starting to see is just better ways of disseminating and displaying that information as well. It used to be a lot of text-based information, and being able to have things like the Aviation Weather Center's graphical forecast for aviation, or GFA, product that they've got on there. Excellent tool for GA pilots and really anybody that's flying, to be able to get kind of a one-stop shop for where is the turbulence, where is the convection, where the IFR ceiling is going to be. So those types of tools that we're starting to see now, I think certainly will make a difference if people know about them and they're utilized.
Yeah, I mean, I'll add on to what Eric was saying there. Absolutely. You got to, I mean, anytime you have a new tool like dual pole or GOES 16 or something like that, you want to make sure that the pilot can and have the best way to use that tool. For example, like Eric was talking about, the graphical forecast for aviation just replaced a text area forecast that had been around for 50 years. And so going away to graphics, pilots love graphics and a quicker way to see that. So as soon as we can apply dual pole and GOES 16 and 17 in a way it's easy to see for pilots, that'll definitely provide more interaction and better tools for them. But as meteorologists, we need to reach out to the pilot community and to understand the best way to provide a product. If we're providing products and we think it's the best way to do it is via text, that's probably not true. Every single general aviation thing, they love graphics. So as meteorologists, we need to reach out to the pilot community and understand the customer base there and which way they would like the information to with these new tools.
One of the newer products that I've used at the CWSU as a result of the GOES data is the GOES lightning mapper, which actually kind of shows aerial extent within the cloud and even outside the cloud of some of the lightning. So we're already seeing some of the benefits of that. It's helping me to figure out which areas I want to use or where I want to issue center weather advisories, that sort of thing. So it's all about flight safety, it looks like.
Hey, Stephen, I got a question.
Yeah, actually, give me one more. I want to give one more answer here too, in terms of the actual technology there. Just kind of throw it in. Things like the 5-minute data, I think, have really really given us a lot better idea of the rapid intensity of thunderstorms and how quickly gaps are filling in. And the 1-minute data is, just out of this world. I think that's probably one of the biggest things we're seeing there with this activity, and makes me wonder what we did before all that, because our mission was definitely very unique. Yeah, sorry about that. Go ahead, Tim.
Oh yeah, no problem. Good point. It used to be in the old days, for forecasters, especially in the Weather Service, we could take familiarization flights with the pilots, and we'd be in the cockpit with them. And since 9/11, those things have kind of gone away. How, I asked the members of the panel, how do you guys, we mentioned in a couple of ways, maybe you get to know what the pilots need, but how do we get to know exactly what the pilots need when it's more of a challenge for us to actually ride along with them?
Pose that question out to people. I'll pose that question out to the group here first. Oops, Eric, you may need to unmute yourself there. I think
Eric's muted.
Yep.
Sorry about that. My words were coming out and you weren't hearing them. I'll speak to it from a carrier perspective. I can't speak to GA exactly, but you know, we used to be, again, back in the old days, our shop was located where the pilots were preparing for their flights. And so we constantly had communication because they could walk right up to us and just, you know, ask, what do you think about this line of thunderstorms that's between point A and point B? Many years ago, that changed, and so we're now co-located with our dispatchers, we're actually in a separate complex, not even right on the airport property where the pilots are. So that guy kind of got curtailed, but we have taken a little bit different, trying to bring that back together during our key times here in Memphis, when the pilots are all here during the afternoon hours and during some of the overnight hours as well. They've come in on their flights, they're preparing for the next one going out. We actually have a meteorologist that is now stationed there in the pilot preparatory areas. We call it the crew lounge, but it's banks of computers where they can prepare their flights. And we're there, and we got a sign, and it's kind of like the doctor is in. You know, the meteorologist is here, and any of them can come up and feel free to ask their questions. And not only do we give them information, but we learn a great deal about the tools we're providing them. How can they be improved? What are you looking at the most? And what really matters to you. So I think that that one-on-one, even though we have 4,500 pilots, they talk to each other as well. And we're finding the more we do this, the more we're getting positive feedback about, it's really great to be able to have the meteorologist there again, where we can get that, personalized briefing. A lot of the tools and stuff that they've got answer a lot of the questions, but there's still a lot of gaps that we can help fill in with that. So that's one of the ways that we've kind of addressed it.
All right, Sean or Paul, any input on that question?
Well, I mean, I think you spoke on a little bit there, Stephen, earlier about having the Mid-South conference that you had there in Memphis last year. That's a great way for the National Weather Service meteorologists. The pilots can get wings credit, FAA wings credit. So, and I've seen around the country, there's about 2 to 4 of those every year. In fact, there's one I'm looking at starting tomorrow in Idaho. It's called the Intermountain West Aviation Weather Safety Workshop in Boise, where they're going to have one day for meteorologists and one day for pilots there. It's very similar to what you did in the Mid-South. So the CWSU and Weather Service folks and regions do, I've seen about 2 or 3 of these every year. And so that's one of the ways to interact with the pilot community and be able to talk and understand, and just listening to them is a great outreach tool. So I think doing more of those would provide a lot of value, and provide a lot of value to the meteorologists to understand, what the pilots are really looking at.
All right, and certainly those outreach efforts have been substantial there too. Thanks for plugging the IWAS, or Intermountain West Aviation Weather Conference. We actually have one of our other committee members out Salt Lake Center Weather Service Unit is really helping to coordinate that. And so it sounds like it's pretty similar to what we did in Memphis last year. I know in the past too, they've had the Southwest Aviation Weather Safety Workshop, which is kind of rotated around the Southwest, and they tend to do that every 2 years. So they're certainly doing a great job with that as well. Sean, do you have any input there on that question?
No, I just think we need to find outreach opportunities where we can. We don't really have an opportunity, or we haven't had too many opportunities here within the ZDC CWSU to go out to talk to pilots necessarily, but we've taken it on ourselves to go out and try to talk to a lot of the tower and air traffic control personnel. So that's another aspect of outreach that we've taken on, not necessarily pilots, but the air traffic controllers, just to see what they need in terms of decision support services from us.
All right, thanks, Sean. I can certainly say too that we've done a lot of extra work out there as well in terms of just getting outreach out there to the customer. Eric kind of touched on this there for a moment when he said that their FedEx shop was actually located there right near the pilots, and it actually used to be kind of that way there for GA customers as well. Flight service stations used to be co-located there right on the airports, and the weather offices are right there as well. And you still see a lot of forecast offices located at or near airport grounds. San Angelo in this case as well, where I work now, is the case as well. But we just don't see the same pilot traffic anymore. And it used to be that there in the weather office, you'd have all the charts printed up, hanging up on the pegboard, and pilots could walk in and just get a weather briefing, and you could develop a great relationship like that. In the short time that I was in Nome, when I started there in the weather service about 10 years ago, they still had that setup, but officially we could not provide a formal weather briefing. We did have pilots who did walk in, just ask for some weather information, and we had to kind of advise them that you're going to have to call 1-800-weather briefing for a weather brief, rather, for an actual formal brief, but we can certainly give you any information you'd like. And last year, I actually assisted at the outreach booth there at the Oshkosh Air Venture in Oshkosh, Wisconsin. AWC runs a booth there, and they usually have CWC meteorologists who help with the outreach there as well. And of course, lots of pilots there. It's a pilot event. And the difference this year is that Lockheed Martin did not have a presence there. I'm not sure why. I'm not really sure why that's the case. But they're the ones who give the over-the-phone briefings, and those are the ones you officially get the pilot weather briefings for. And so we had a lot of pilots coming up to us asking for weather information. We had to keep telling them, we can give you this weather information, we can tell you about it, but it cannot count as a formal weather briefing. And it's kind of unfortunate that interaction is not what it used to be. And I definitely talked to a lot of pilots who remember those good old days, as they call it, and they miss that. They like to be able to interact with an actual meteorologist and not have to call someone on a phone. So, you know, it's kind of unfortunate that interaction is kind of lost, and now this newer generation of pilots is not used to doing that. We're now in the electronic generation where we're able to look at things on our, you know, on our phone, on a tablet, on a computer, and while those tools are great, we have to remember that people who are not meteorologists, they may not interpret it the same way. In fact, we've seen, unfortunately, some deadly results of that, and Paul's shown some examples of that as well. So, you know, that's the unfortunate thing there. I think the interaction it's another untapped area for partner interaction, and some better training on our part too could really help, and us to reach out and say, how can we help you? I think that's probably what needs to get better, and I think we're doing a great job with that so far. Places like the Center Weather Service units have done a great job. Obviously, I know, you know, Paul, you're, you know, beating down the doors there and trying to get as much safety stuff out there as well. And, you know, Eric, I know you're trying to do a lot there in-house there at FedEx as well. And so it's great, but unfortunately we are still seeing a high accident rate, and you know, there's got to be more that we can do to help bring that accident rate down. So with that, let's see here. I'll maybe pose one more question here, and it's it's kind of along the same lines of what new recommendations do you have to improve aviation safety?
I know what Paul's thinking. He's thinking PIREPs, because I was thinking the same thing. Improving reports from pilots in the skies that are then accessible to the pilots that are following along behind them to know what is coming up. The best way to figure out what is going on up there without sampling it remotely is for somebody to tell us, we just went through this. And so I think PIREPs is a big one. And the other one I'll plug as well is we would love to see more radars in places where there are gaps, especially in the Western United States. There's got to be a way to, and not even just in the Western United States. We've got a pretty large hole southwest of Memphis, below about 10,000 feet over southern Arkansas. So we would love to be able to get more technology out in the field.
Yeah, I'll just pile on to what Eric said about PIREPs. We've seen a lot of accidents where the weather information is not necessarily passed along. So if there's somebody out there that can make an easy button. There are electronic flight bags out there where you can put in your PIREP information, but a lot of these GA pilots are just one pilot in the cockpit. And so, you know, first of all, we want them to fly the plane, you know, and if they have time to do the other things. So if there's like an easy button that somebody could develop for the electronic flight bag, they could just press the button, and then when they're safely on the ground, then they can enter the PIREP information in. That would be easy, and make an easy button for air traffic controllers too. There, as Stephen said, there's 21 different centers. There's 21 different ways of getting PIREPs into the system from each one of those centers. So if we can make an easier way for air traffic controllers to get PIREPs into the system, that would go a long way into helping them provide more feedback to the meteorologists there as well. So, yeah.
Yeah, Sean, any comments on that?
Well, I know that there are actually some systems that some commercial airlines use, like the TAP system. I'm not exactly sure what that actually stands for, though. But you know, pilots can actually kind of send these PIREPs out, and it's not a manual thing. It's just an automatic thing. So they just, I don't know if they press a button or what they do, but some of that stuff, the problem is it's proprietary, though. So, you know, trying to share across the aviation community, the aviation industry it's going to be tough, because it's kind of a money issue in some cases, which is unfortunate, but that's kind of what it boils down to. So safety and money.
Those are always the two big players there, safety and money, and just about everything you do in our business. Oh boy, yeah. Well, I can definitely vouch for Paul as well. It's certainly been a big push for PIREPs over the past several months there before I left Memphis, and we were getting quite a bit more. Their requirements kind of got a little bit tightened. We definitely saw a lot more information though come across, and a lot more than we'd seen in the past. So in many cases, it's helpful, but unfortunately, this does cause challenges there with workload as well. And as Paul mentioned, there's 21 different centers and 21 different ways to do things, and unfortunately we're seeing that as well. So and there are better ways to handle that through system and get some better improvements, but it is a slow going, and unfortunately that's just how it is at this point in time. We did have one question earlier about jobs available at FedEx Weather, and obviously Erica talked about that. A little shameless plug there. Obviously, I mentioned I left Memphis Center Weather Service Unit about a month ago. So my old job is available. I'm just going to throw that out there. As far as I know, it's not been advertised in USA Jobs yet, but if you have any questions about that, you can feel free to contact me. I would love to tell you all about it. Great set of partners to work alongside there. And if you're into DSS, it's as DSS as you can get. Let's just say that right there. So with that, I'm going to go ahead and wrap it up here as we're out of time. Thank you so much, Paul, Eric, and Sean, for all your informative talks. I think we all shared a lot today, and there's certainly a few tidbits that I actually wasn't quite aware of as well. So I can goes to show our perspectives and our customers are a little bit different in different parts of the country and different agencies. And for a great discussion afterwards, I think that's some good things that are brought up there as well. Thank you also to Tim Bryce as well as Becca Mazur, if I'm pronouncing that correct, for co-hosting and kind of handling all the logistics behind the scene and social media there during the presentation. That's all we have for now. Please join us next month with the local chapters committee as they will share with us their experiences hosting a local conference. This one looks like it's going to be great for students and professionals alike. The webinar will be on October 3rd at 10 a.m. Central Daylight Time. Again, that's October 3rd, 10 a.m. Central Daylight Time. Thanks again, everyone, and we'll see you next month.